I remember what the other thing I was going to say was, in the middle of this day at some point, very soon, we're going to have a homework take-up time. So you got a couple of questions that are driving you nuts. You're like, how do we do this one? That'll be the time. So I'm definitely going to dedicate some time for that as well. That's what I forgot to say. Integer operations with powers. Did I delay long enough? You had time to copy this down? This title? Yeah? Good. Going to keep it moving today. Integer operations with powers with the fancy roll in. Here we go. What do each of the following powers mean? Boy, a whole slide dedicated to one little idea. There'll be one moment in this slide where you go, oh, I get it. And that's all you really need from this slide. So quickly, 3 to the exponent 4. This went really well in the quiz. Everybody knows what this means. It doesn't mean 3 times 4 is 12, which actually happens to smart people a lot. Smarter people will make that mistake, not people who are weaker at math, because they'll see 3 and 4 and their brain will go, 12. It just jumps into your brain. So that's why we get you to write it out a couple of times, just to remind yourself that 3 to the power of 4 is 3 times 3 times 3 times. This might be the exact one I used in the quiz, was it? Did I use this right on the quiz? Oh no, this was in the other PowerPoint. So that's 81. That's not what I came to talk to you about today. I want to talk about negative numbers with exponents. So it's integers with exponents. So let me write this out, and this will not be surprising, I don't think. This isn't the big moment of the first slide. Negative 3 to the power of 4 means it's negative 3 times negative 3 times negative 3 times negative 3. And the only question for that one is, do you know whether it's going to be positive or negative when it's done? If you go negative 3 to the power of 4, if I go negative 3 times negative 3 times negative 3 times negative 3, do you get positive or do you get negative? I've kept my promise so far, and I've never called on anyone who doesn't have their hand up, and I will keep that promise. But I encourage you, if you're not going to raise your hand, that's fine. Every time I ask a question, though, in your mind go, I think it's this, and then compare your answer to what we end up talking about, okay? So at least you're checking in with yourself, you know? Don't just drift off to sleep if you're not going to be an answer person, okay? What is negative 3 to the power of 4? Is it positive or negative? Positive, yeah, because what happens is this negative times negative is a positive, this negative times negative is a positive, and the whole thing ends up positive. Or negative times negative is positive, times negative it's back to negative, and then times negative it's back to positive. And you might be ready to make a rule, and there's a great rule coming up about exponents and how they come up. There's some great rules coming up about that, but you might be ready for that already. Okay, if you've drifted off to sleep, or if you haven't even woke up yet, this is the moment in this first lesson that you really need to get down. The rest of it is not too bad, but this is the big moment. Negative 3 to the power of 4. Now you might argue with this that you don't think this is what it should mean, but in math, this is what this means. When you've got negative 3 in a bracket, it means you repeat the negative all the way through. When the negative's out front like that, due to BEDMAS, you do the exponent first, not the negative first, and so it looks like this. Really write that one down. Give it the red highlighter, the star beside it, a big circle, because that's the big moment of this lesson, is understanding that if that negative's not in the bracket, it doesn't get repeated. In fact, I'm going to tell you one of the questions on tomorrow's For Real quiz. It says, explain why, and I don't know what numbers I used, actually, but it's something like this, and I might actually be giving you the exact question here, and I don't care, it's that important. So I said something like, explain why negative 9 to the power of 2 is not the same as negative 9 to the power of 2. I literally tell you that right on the quiz. I go, explain why these two things don't come out to the same value. Saw a couple of frowns at that. It looks the same, doesn't it? But we need to get to the bottom of how it's different. Have I explained enough? Can anyone explain why these two things don't come out the same? Yeah, one you do the exponent first and one you do the negative first if you want. So in this one, and I'm preparing you for one of the questions on the quiz right now, in this one, the negative repeats. So when it says explain, you're like, how do I explain it? All you got to say is, in this one the negative repeats, in this one Negative doesn't repeat. If it's not in the brackets, it doesn't repeat. And by the way, your calculator knows. If you put it in with a bracket, it'll come out to positive. If you don't put it in a bracket, it'll come out to negative. And that's correct. But some calculators automatically put the bracket in, and some calculators automatically don't put the bracket in. So you're going to have to get to know your calculator when you type these in and make sure. Ooh, homework check-in / calculator. Today's the day where we want to take inventory on what calculator you're using, and I'll give you a thumbs up or a thumbs down. Go, hey, that's a great one. Or yeah, that's fine. That one will work. Or it's like, oh, that thing's got to go. We'll have a little ceremony. We'll put it on a little boat, send it out to sea, and let it go. It's time to move on. So when it's negative 3 to the power 4, like the one on the screen here now, the negative goes up front and only the 3 gets repeated, and you get a negative number instead of a positive number. Is there any questions about that? Is it good? Are you like, okay, I get that now? You may look at it and go, that's not what I would have thought. It is, and that's fair because it's weird looking when you first look at it. But that's how we do it in math. Any questions on that slide? More time on this slide? All right. Oh, negative 8, sorry. Here, I kept the bracket there. You don't really need to keep the bracket. If you know what you're doing, you'd probably just jump like I did there. Just jump, you'd write it out one line and jump to the end. I did it all here for clarity, but you don't have to worry about that. You can do it in however many steps you want. Another way to think about it, if you're having trouble with this whole thing, is when we write negative 3 to the exponent 4 and the negatives out front like that, we really mean that 3 to the exponent 4 sort of in a bracket. We sort of understand that it's by itself. So if that helps you, if you totally get that, you don't even need to copy this down. But if you're like, I still don't really buy it, I still don't really get it, write this down because that's really what we mean by all this. Ready? Ready to go? Yeah. Okay, so take a moment. This says, power. Oh, that's the same title as before, powers of negative numbers. Circle the following powers that give a positive result. So here are 7 powers. Take a look at them, write them all down, and take a moment and think to yourself, which one of these will come out to be negative? Challenge yourself to not use your calculator, but if you're dying to use your calculator, go ahead. But take a look at these and figure out which ones will be negative. I'll give you a couple of minutes to think about that. Well, a couple of seconds anyways to think about that. Can't resist singing in the background. If you're ever watching these videos at home, you're going to have to listen through all my singing as it goes along. Oh yeah. Uh-oh. Okay, I don't want to rush you. I don't want to bore you. I want to find that perfect spot in between. Who wants more time? Okay, we're good. Someone want to suggest one that they know will give a positive result? Did I say negative out loud a minute ago? We want ones that want a positive result. Tell me one that you know from there is going to be positive. I'm going to ask why immediately after, but hopefully if you know the answer, you're going to know the why. Yeah, tell me one. Negative 2 to the power of 4? How do you know? She's got the rule. She already knows the rule. Maybe last slide you already knew the rule. If it's an even power, and the negative's in the brackets, because we talked about that too, and the negative's in the bracket, then you know. And now we've already given away all the answers. What are the other ones that have even powers? This one, this one, this one. I think I circled them all in the PowerPoint. Here they come. Now, if you don't buy it, if you're like, I still don't get it, try writing one of these out and see all the negatives you get. Because with positives, you get pairs of negatives, and the pairs of negatives turn positive. With odd, you get pairs of negatives with one extra, and that's how it ends up being negative. Did that go well for you? It was too easy? I gave you too much time? Yeah? All right. Well, here's the conclusion if you need it in a separate box. If it's unclear at all, here's a separate box with the big conclusion. A power with a negative base will give a positive result if the exponent is even and a negative result if the exponent is odd. I think that sentence is too long. I think it could have been, that sentence could have been done a lot shorter. You could have said negative base, even, positive, odd, negative. If that's all you write down for your note there, maybe that's better, because when you go back and look at it, you'll be like, oh, that's easy to understand. Yeah? So here's some examples very quickly. State whether each result is negative or positive. Challenge one coming, okay? Not the first couple. First couple should be easy. Negative 8 to the power of 54. It's going to be a really big number. But is it going to be positive or negative? Absolutely. It's going to be positive, because that's an even exponent on a negative base. Negative 2 to the power of 113. Again, a giant number. That's not what we're asking. Is it positive or is it negative? Negative. How come? Exponent's going to be odd. If I were to write this all out, I don't want to have to write it all out, but if I did, there'd be one extra negative. Oh, sorry, this one. Negative 5 to the 13. And the answer already came up on the screen, but you have to be careful. This is the one's a little more challenging. I'm going to help her out. I agree that part will be negative, because the odds exponent is on there. Yeah, because then it goes negative, negative. Let me rephrase the question. If you were to write this out, we don't want to write it all out, but if you were to write it all out, how many negatives would there be? Yeah, there'd be 13 from here, and then a 14th there. So don't get carried away with this rule. It's a good rule, but you have to use it in context and make sure you know that would take care of this part. That part would be negative. And finally, this one, negative 6 to the power of 8. I'll let you think about that one for a second, because that one's on the quiz. The big for real quiz tomorrow. There's a big quiz tomorrow. Are we going to be ready? Yeah, we're going to be so ready. Look, we're going to have some time to do page 41 to 13. It's exactly the prep you need to get ready for the quiz. If you can do this stuff, you'll do great in the quiz, and you're going to have lots of time to work on that later. I gave you some time to think, because I really want you to get this right, because it's the big point of this PowerPoint. Is it going to come out to positive, or is it going to come up to negative? Let me just do a little prayer. Okay, go. Negative, yes. Now, she's right. But then I'm going to play games here a little bit. I'll always warn you when I'm going to do that. I'm going to ask her to explain it, and I'm going to try and confuse her. You ready? But this said if it's even exponent, it comes out to positive. Why does this one come out to negative? Okay, she liked this. She went to this explanation right here. She said you can visualize it like this. This is what's actually going on. And she liked that, and she used it. So on the quiz tomorrow, when you do your explanation of this, you can totally use this, because it seems like she likes that. The other explanation is the negative doesn't repeat if it's not in the brackets. That was my explanation. Whichever explanation is better for you, I'll accept both. You don't have to say my explanation. Back to here. This thing comes out to negative, because the negative doesn't get repeated. Let me rephrase it one more time. This seemed to help people in previous years. If you were to write this out, how many negatives would there be? just one. Yeah, it doesn't repeat. Yeah, that helps sometimes to think these things through as go, how many negatives would there be? Questions on that slide? More time? Order of operations. Well, after we learn something new, we're always going to put it back into bed mass and make sure we can handle bed mass in the middle of all of it. So here's an example to evaluate. We'll go through the whole bed mass thing on this. Negative 2 to the power 4 plus negative 1 minus 1 to the power 3 plus 5 bracket negative 2 to the power 4. Okay, here we go, bed mass. Brackets. Is there something to do inside a bracket here? Yeah, right inside this bracket, negative 1 minus 1. And so we handle that right there. Negative 1 minus 1 is negative 2. Then, there's nothing else inside brackets to handle. Now I go after exponents, one at a time. This first one, negative 2 to the power 4. Will it come out positive or will it come out negative? Negative. There's only one negative. That negative doesn't repeat. How about this one? Does it come out to be positive or negative? That one comes out to be negative because it's an odd exponent. Not because there's a negative out front, because it's an odd exponent. And this one, negative or positive? Negative 2 to the power 4. Positive this time because it's an even exponent. You see how this rule, seemingly simple rule, will throw a whole bunch of loops at you as you go and do a question, because in one question you have to use the rule 3 different ways. So 2 to the power 4 is 16, 2 to the power 3 is 8, 2 to the power 4 is 16. Now, you can do those in your calculator, but I encourage you in your calculator to find that button that does exponents. We talked about it the other day. Your exponent button might look like a Y with a little X, or an X with a little Y like that, or a little top hat of a house deal. Good button to check out and find on your own calculator. Well, after that line's done, then it's just bed mass again. You just go back to this, do the multiplication. 5 times 16 is 80, and then just go left to right. Negative 16 minus 8 plus 80. Actually, folks, after seeing what I've seen, you're in good shape. You don't have to show, when you get down to the addition and subtraction line, you don't have to show your individual steps. Just give me the final answer. I'm more worried about these steps up here than the final answer. Okay? Any questions about that example? Need more time there? Who needs more time? Yeah? Is there anyone who has a calculator but didn't bring it today? Okay, so just let me know. When I come to check calculators, let me know that too. And again, whatever you're using calculator-wise, if you're having trouble, because you see these get more and more calculator central, these questions, if you're dying to have one, let me know and I'll bring over the box of calculators here, and you can pick one out to use. I'll carry it over so you can just pick it out and we don't have to both be in contact with it. Did I give you enough time? Anybody still need more time here? Listen, my young daughter, who's 7, and at 7, I don't know if you remember, everybody loves school still at 7. She loves school, and she had some homework, and she was excited about it. In the middle of doing her homework, she just broke down in tears last night, just started crying. And that's not really what she's about. She does that, but it's just not very often that she does that. So we're all just staring at her, waiting for it to work out, and we consoled her and worked it out. As it turns out, she's had a headache for 3 hours, and it had got to her. In the middle of all this COVID stuff, it's easy to try to keep sledding through hunger, fatigue, and thirst. And what had happened is we got her a big jug of water. We went and sat down for half an hour. We got under a fan. She drank a bunch of water, and her headache went away. No Advil. Yes? Don't go right to the Advil. Most headaches are water. Lack of water. Too much sugar, lack of water. So keep drinking. Yeah? Keep taking care of yourself. You feel a little drowsy in the morning, go for that walk on the break and so on. Okay? Got to take care of yourself or you're going to break a little bit. Oh, here's a beaut. The reason I put this one up, it's not any harder than the previous one, is because I want to talk about square roots for a second. We don't do a lot of square roots in the middle of these questions, but I did want to throw it up because it's hard to know where this fits in. So in the middle of this, I'm going to explain where square root fits on the old bed mass scale. Okay? Okay, so we start with square root, or start with bed mass. inside brackets. Is there something inside brackets to do? The answer is yes. And this came up a couple times yesterday where people were like, okay, once I'm inside a bracket, then what do I do? And a couple people on the quiz had a little bit of speed wobble on these. Once you get inside a bracket, like this part right here, do I have my pen here? No, I don't have my pen here. So pen. Yellow. Once I'm in here, then I sort of start bed mass over again. I go, okay, now, inside that bracket, is there any brackets? And the answer is no, nothing I can do inside brackets. But then I do the exponent first, yeah, inside the bracket. So on that first line, all I'm going to do is this exponent here. It's a negative power, so negative 4 times negative 4 times negative 4 is negative 64. I'm still on the bracket stage, still doing inside brackets. Negative 2 subtract negative 64. Okay, that takes a little thought. And that's too big to really do on drawing or anything like that. But you might be able to visualize it. Negative 2 plus 64. It'd be like 64 minus 2. I can encourage you to try and do these things. But then punch them in the calculator to make sure you're getting right answers, right? 62. Now here's the big moment. Where does square root fit on the old BEDMAS scale? A square root, it's an exponent. And it's not just, oh, we treat it like an exponent. As it turns out, a square root is an exponent. And you'll find out more about that in grade 11. If you're not sure and not convinced I know what I'm talking about, after the lesson, type in these two things in your calculator. Type in square root of 16, and you should get answer 4. But also, if you do 16 to the exponent 0.5, you'll also get 4. Woo! Seems like we're just making stuff up. But that is the way it works. There's a lot of explanation that has to go into that about why square root is like an, it's not like an exponent. It is an exponent, but there's more to understand there. In grade 9, all you have to remember is square roots get done when exponents get done. So I do this exponent. Ooh, big moment. Let's just check again. See if you're ready for this question on the quiz tomorrow. Will this come out to positive or negative? Right here. Negative. How come? Practice your explanation right now. That's an even power. Why in the world does it not come out to positive if it's got an even power on it? Anyone want to practice their explanation of this thing? Give it a go. Because the negative doesn't repeat. She's taken my explanation from over here. We've heard the other explanation as well. So you've got two available now. Maybe you've got one of your own, but how you understand it. Maybe you're just going to write it out for me and say, look, that's a great solution too, where you just go, let me just show you why it's different. Yeah. Anyways, this comes out to negative 81. Square root of 16 is done as an exponent, is 4. And then, like I said before, you do not have to show me any more steps once you're down to addition and subtraction. You can just punch those in your calculator, try them in your head, whatever you like. Questions about that? More time? Who needs more time? That was really fast. You definitely need more time. I'll give you a couple seconds to copy that down. And I'll try and figure out what just happened here because I messed something up here. There's another weekend idea for you. If you're dying to learn how to do the Rubik's Cube, or how to do the next Rubik's Cube, maybe you can do a 3x3, but you want to learn the next one, come and see me. I'll tell you what to buy, and then I'll help you with what to do next. This is one of my favorites because it's so weird. More time there? Did I buy you enough time there? Last slide. So if your brain is out of gas for the morning, this is the last slide, maybe of the morning. We'll talk again about exactly when you want me to teach after that a little later. Okay, this is weird and so important with everything that's going on. It says evaluate the following expression if x is negative 4 and y is 2. Let's ignore that first sentence for a second. Let's say you just missed that sentence. You didn't even read that, and someone popped that on your page. 3x cubed plus 16 over negative y cubed. Now, let me be very clear to explain. what this is about. This has a bunch of variables in it and could represent something in science or business or technology. It depends on what field you might be going into. And it won't necessarily be this simple, but it won't necessarily be this hard either. You've got something with some variables in there, some values in there. When you first look at this, it's impossible to know what the value of this thing is. It has all sorts of different values, depending on what the x and y are. So, if you just read this part, remember I said we're going to pretend we didn't read this part. If you just read this part and someone said, what's this equal to? You could legitimately say, I don't know. There's no way to know. Unless you tell me what x and y are, there's no way to know what this value is. Having said that, this question does tell you what x and y are. This is very important in this whole question. You can't do anything until somebody tells you what x and y to use. But they did. Now, set your pencil down for a second and just watch the PowerPoint. This PowerPoint is really good at showing what substitution is all about. I want you to watch what happens very, very carefully. And we want at least two things when it's over. Two things that happened here. Are you ready? Are you watching? Yeah, okay, here we go. Here it comes. Watch, watch, watch. Am I in the way? Still watching? Okay. Watch again. Once that is done, we got to talk about, I'm going to rewind it and we're going to watch it all again, but once that is done, then things are pretty straightforward. Use your bed mass and solve this out, okay? So I'm not saying that's easy, but we sort of know what to do. So let's try and establish what happened. What two things did you see happen? There might be three or four things actually, but let's start with two things that happened in that whole procedure. Yes, the x disappeared, gone. We're substituting in for it. Often we say subbing. We're changing the x to the number that was given, and then we change the y to the number that was given. There's one other important thing that happened with the number as it went in, though. Did you catch it? Yes, it's such an important piece of this move is to make sure you put it in brackets because it comes in all as one piece. Last night I went to Subway and had the turkey sub, and when they subbed, they immediately put it in a package for me, and that's what happens with this kind of subbing too. Well, it's different kind of subbing. I'm just throwing that in your brain, so maybe it latches onto something in your brain going, oh, when subbing, it has to come in a package, and the package here is these brackets that it comes in. So let's watch it again and make sure you see those two things happen. I'll narrate it this time. X equals -4 comes out with a bracket, always comes with a bracket, and then it comes over and it replaces the x. The x disappears and -4 pops in there. Do again with y. The y comes with a bracket. And then the y pops out and you put the y in like that. How will it look on your page? Well, you don't have to draw all that. Here's what you have to draw. You'll have this line and then you'll have this line. Take a moment and copy down those two lines and see if what I said happened is that the x and y disappeared and they were replaced by the numbers in brackets. My voice is going. Can you see in the way that's written down that the two things I said happened? The x disappeared and was replaced by -4. But the -4 came in a bracket. The y was replaced and was replaced by 2, because that's what it said to do. But it was replaced with a bracket. Now, once that's subbed in, we do BEDMAS. So we got some exponents to take care of. Negative 4 cubed becomes negative 64. 2 cubed becomes 8. A little multiplication to do on the top. 3 times negative 64. Probably need your calculator for that. But hey, after yesterday's lesson, maybe you can try them in your head a little bit. Experiment. See if you can do 3 times 64 in your head. You'd go 180 plus 12 is 192. You know, it's possible. Add those things in the top and then divide by the negative 8. Answer comes out to 22. Just a little note here. With fractions, we always evaluate the top, finish off the top, then we finish off the bottom before we do that final division. That division is done as the last step when you're in a fraction like that. Seems to violate BEDMAS, but there's a sort of an understood thing with fractions is that the numerator gets divided by the denominator. Do you have any questions? I sort of sound like the guy from the fair there for a minute there, did I? Do you want to go faster? Do you remember that? Not fair people? It's a Paris Fair thing. Questions here? More time? Oh, that's it. That's done. So let's just talk about the plan here. Okay? It's 9:45. What time's our break? 10:05? Yeah, because it's the same every day now. Let me just check my list. I'll write it on the board. I kept it stuck in the air yesterday. $10:15. 10:15. Okay, 10:15 is when they want us to go. We may have got that wrong yesterday, but 10:15 is when they want us to go. So here's the big plan. We did that lesson. We'd like to do a pre-quiz on fractions. Let's do it right after the break. Okay? Let me get some open time to work right now. So that pre-quiz will be right after the break. We're going to do that at 10:25. Then we will do work time. The homework for that, what I just taught, is right there. Okay? Then you've got this upcoming quiz you want to do some review for. The work time for that is right there. So the next possible time for me to teach is this lesson at 12:25. In fact, I'm going to teach at 12:25. I am. I'm going to teach that lesson. We'll get that out of the way. Then I'll put the last lesson of the day, I'll put 1:35 and I'll put a question mark. It's 2 slides. We'll see at that point if you're feeling pretty good. I mean, I know this list looks long right now, but we'll see how that goes. In here at some point, I'll jump up and answer and say, okay, let's take up some questions. When I feel like you're starting to drift off to sleep at some point, when I feel like, ooh, it's getting a little too light in here. And we'll also do our letter at some point. I do have a question for you, though. It's really quiet in here. And that's great for getting work done. It is. But would you prefer that I played light music in the background or not? Is the dead quiet the perfect environment, or is like a little background music better? Music, thumbs up. Silence, thumbs down. Oh, 50-50. Okay, you know what I'm going to do then? We're going to have different times of the day. Yeah, there'll be times of the day where I play a little music and some of the times of the day where I keep it silent. So you'll have a little bit all the time. If you're a music person, feel free to bring those headphones along. And now I'll slam my mouth shut so you can be busy up until your break at least.